This is an instructional video on using the desaturation utility in CCDLAB for desaturating the counts of a bright source. So we see that there is this option to correct the background out of the counts, and obviously we should correct the background out of our source counts. I mean, sometimes the background is negligible, especially compared to a very bright source, but in any case we should generally always correct the background out. So we need to determine what the background is. So we need to do some photometry on the source. So to do that, let's get our region of interest box centered on the source. We move this around, and once we have it within the box here, we click to fix it. Then we can double click on this window anywhere, and it will center the brightest source. So to do the photometry on the source to determine the background, we go to point source extraction here. Then we go to sub-image region of interest, curve of growth, and let's perform curve of growth on this source. So we want to check view COG, view curve of growth, and do cog, do curve of growth. So here we have the result. So we can see that the counts for this source increases with radius, the number of pixels inside a radius, and then it tapers off to a constant level background, and that background we have fit with the last 6 points here, which is indicated by this red dot. That's the part we have fit, and the slope of this line gives us the background rate per pixel, which is right here, 0.0286 counts per pixel. Now this value, once we have done that, is conveniently inserted automatically for you into this text box. Now, if your bright source is surrounded by other sources, so that you cannot form a large box, say with a half width of around 50 pixels, or a box size of around 100 by 100 pixels, if there's other bright sources in the way, then just move to some other source and perform the same thing, because all you want to extract is the background, or you can even go to an adjacent region where all you were doing is fitting background, and then it can fit the line to the background itself. In any case, we have background determined, and we have this recentered on the source. Now, before doing the saturation correction, we want to shrink this back down to capture the source only. If we match the contrast to the window, we get a better sense of the extent of this source, because we want to capture its wings counts too. So you can see that there's some wings of this source, the wings of this Gaussian, approximately Gaussian profile extending all the way out here. So if we shrink down to about this size, we're going to be capturing source counts. Of course, there's background counts in here as well, but those are going to be corrected out. But with a box size this size, we are capturing pretty decently the whole PSF, point source function, point source profile of this source. That's good. So now we simply go over to UVIT and desaturate our ROI counts. And our background is still in there, of course. And so we double click this menu item, and the result comes up here. So this table is copied to your clipboard, so you can simply paste this into Excel or any other place you would like it. And this list gives us the results. So for example, it gives us the window size, the position, gives us what the flat was for this region. The ROI exposure map is this term here, and it's just unity 1 because there was no exposure map differential here, because this is an interior region. It's not by the edge here, which is where you have exposure map differentials. Gives us the raw count, the number of frames, a bunch of information. Finally, at the very end here, this is the value you want for the desaturated count rate per second for this source. That's this term right here. Now, to see what the comparison or what the correction actually was, we go to ROI, we look at this line here, ROI exposure count rate per frame. So this is your raw exposure, your raw observation count rate per frame. So it's 0.768. So that is actually quite high, because saturated would be 1 count per frame. So if you imagine Poisson statistics, once you get up around the frame rate, you're going to be saturating the detector like crazy. So at 0.76, 0.77 counts per frame, that's very near saturation actually in terms of Poisson statistics. And then this next value here is actually what the correction is, the desaturated correction. So we actually go from 0.77 counts per frame approximately to a true Poisson statistics corrected count rate of 1.37. So this source is actually saturating the detector, because fully saturated, if everything was, simply linear and Poisson statistics didn't apply, you would simply have one count per frame being the saturation. And so here, the count rate is actually 1.37 counts per frame, so it's more counts than can be counted in each frame. So, but then you apply Poisson statistics. Obviously, there's going to be some non-detections in those frames, and so that's why you only detect 0.77 counts per frame. So it's quite a significant correction for this point source here. This is a very bright point source, actually. So that is your final source. This is the one that you use for your photometry for this source, is this very last line.